Okay, let's unpack this. We're doing a deep dive into roofing systems today, and specifically looking at something called liquid applied roofing.
That's right.
We've been digging through some interesting articles and notes you sent over, and they make a really strong case for this approach.
Yeah, they do. And our mission here really is to pull out the key insights, maybe some surprising facts about why this liquid applied method is highlighted as, so innovative and resilient.
And crucially, what this actually means for you if you're maybe planning a building project or even just thinking about renovations down the line.
Exactly.
So, right off the bat, one of the biggest points in the material seems to be about creating a seamless barrier. When you think of traditional roofs, you picture sheets, maybe shingles, panels overlapping.
Precisely. And the thing is, those overlaps, the seams, even the mechanical fasteners like screws or nails holding things down, that's often where failure happens. That's where leaks tend to start. A liquid system, as the sources describe it, it goes on wet and cures into one continuous monolithic membrane.
Ah,
So it basically eliminates thousands of those potential weak spots right across the roof surface from the get-go.
okay, so it's not just about looking smoother. It's fundamentally about building in more reliability by just getting rid of those potential failure points. Okay, seams are out, but buildings move, right? They settle, materials expand, contract with temperature. How does a liquid membrane handle that? I saw flexibility mentioned quite a bit.
That's a really important question, yeah. It touches on long-term performance. Traditional, more rigid systems, they can become brittle, prone to cracking or splitting as the structure shifts or you get those big temperature swings. The liquid systems we're looking at here, they're engineered with inherent flexibility. They stick tight, but they can reportedly move with the building quite significantly.
So it sort of stretches and contracts.
Kind of, yeah. It's not just basic give, it's about preventing those tiny stress cracks that can form over years and years, which, again, is all about stopping water getting in.
Right, like it forms this tough skin, but one that's adaptable to the building's subtle movements. Interesting. And another thing that jumped out at me, you can often apply these right over an existing roof. Is that right?
Yes, and this is a huge practical advantage that the sources really highlight. It often means you can skip the really disruptive, labor-intensive process of a full tear-off.
Ripping off all the old layers.
Exactly, layer by layer, and minimizing all the prep work underneath. That saves a lot of time, cuts down on disposal waste, and naturally lowers labor costs.
Sure.
Plus, as noted, they're generally lighter than many traditional multi-ply systems. That can be a real bonus for the building structure, reducing the load.
Okay, time, cost savings, less mess. It's massive for any project. All right, so we've got keeping water out, handling movement. What about energy performance? The material talks a lot about high reflectivity.
Yeah, this is where it connects to the bigger picture of building efficiency. Many of these systems use highly reflective top coats. The sources mention some pretty impressive figures, often exceeding 80% solar reflectance.
Wow, over 80% reflectivity. What does that actually do for the building day to day?
Think of it like putting a really efficient mirror on your roof, but for heat. Instead of absorbing the sun's radiation and heating up, the roof surface bounces most of it away.
Okay.
A cooler roof surface means much less heat gets into the building below. This directly cuts down the work your HVAC system has to do, especially in peak summer heat.
So lower cooling bills.
Significantly lower cooling costs, essentially, and improve comfort inside without just blasting the AC. It also reduces the thermal stress on the roof material itself, which could help it last longer.
Huh. So it's not just a passive barrier. It's actively working to help control the building's climate and maybe even extend its own life. What else did the sources say about durability?
They definitely highlight resistance to the stuff that usually breaks down roofs over time. UV radiation from the sun, chemical exposure from pollution, maybe just general weathering.
Right.
This resilience is key to them potentially having longer lifespans compared to some conventional systems. And that translates into, lower maintenance needs and fewer repair costs over the life of the building.
So let me try and pull this together from the articles and notes. We're looking at systems that are, seamless and flexible, making for a really reliable waterproof barrier. They can offer faster, less disruptive installation, potentially saving time and money. They contribute actively to energy savings through that high reflectivity.
Yeah, often very high.
And they promise long-term durability with hopefully less upkeep. It really does sort of reframe what a roof can be, doesn't it?
It certainly presents a compelling case. based on the performance metrics discussed in the material, or maybe rethinking some of the more traditional approaches.
So, wrapping up, what does this all mean for you listening? Thinking about these long-term benefits, things like potentially lower maintenance, real energy savings, how might rethinking a fundamental component like your roof impact not just one single building project, but maybe those broader goals we all have, like sustainability and managing costs effectively over time. Definitely something to consider as you plan your next steps.